All right, in this video, we are going to go over 6.2 practice number 3. So it says circle the initial value in blue. So the initial value is going to be our A value. That's the number that's in front. It is also our y-intercept. So then it's 0, 6. And you can get that on the table as well. And then it says circle the y-intercept, which we did, and then circle the constant ratio, which is in red. So the constant ratio is the pattern, and how you can do that. Start from the bottom up. 1.2 divided by 6 will get you 1 over 5. If you don't want to deal with decimals, you can do 6 over 30. That will get you 1 over 5, or you can even do 30 over 150. We can double check that, in fact, it gets you 1 over 5. 150 times 1 over 5 gets you back to 30. 30 times 1 over 5 gets you back to 6, and so on and so forth. Now it says circle the initial value in blue. Once again, initial value is your A. You can find that for your y-intercept, 0, 2. You can find that on the table, 0 with comma 2. Circle the constant ratio in red. So that is what is holding up the x value. So that's going to be 3. How you can find that, pick your y values and work backwards. 18 divided by 6 gets you 3. Or you can do 6 divided by 2 gets you 3. You can confirm that by multiplying. 2 times 3, yes, that gets you 6. 6 times 3, yes, that gets you 18. And then it says circle the exponent in green. Just want to remind you that the exponent is the letter, the variable up in the air. All right, for here it says look at the graph and table below. You'll need to find the initial value. So once again, the initial value is the y-intercept. So that's our A value. And then our B value is what we just got done writing in red. And how you do that, you work backwards. So I'm going to do 100 divided by 20. And I'm going to get 5. You could do 20 divided by 4 and get 5. That is going to be your B value. And then you put it all together, it's 4, and then times your B value, raised to the x power. So you can confirm that by typing it. You can use parentheses or the multiplication symbol. And it says good work. Now for the next graph, it's honestly the same, but now it's asking you the key features. How far left does your graph go? How far right does it go? It goes all the way to the left. It never ends, so we call that negative infinity. How far right does it go? It goes to positive infinity. The range, the bottom of the graph is trying to get to 0. And then it never stopped reaching upward. In this case, the y-intercept is 0, 4. And then the asymptote is y equals 0. So it says draw the asymptote. That's that line right here. Remember, it's y equals 0. It's trying to reach 0. Also, here's the y-intercept. 0, comma 4. So the bottom number that the range is trying to reach, that is going to be the same number for your asymptote. Just giving you a heads up. All right, slide number 5. Our A value, once again, is our y-intercept. So you can find that on the graph or in the table. And the B is our multiplication pattern. Okay, so I'm going to pick, I don't want to pick any of the fractions. I'm going to pick 2 divided by 6. Remember, you're working backwards. 2 divided by 6 gets you 1/3. You could do 6 divided by 18, and guess what? That's going to get you 1/3 as well. So this is your B value. You don't have to do it more than one time. I was just showing you that it works every single time. Also, here's a hint. Notice that we start at 18 and we're going down with our y's all the way to 2/9. If you are decreasing or decaying your y values, you're going to have a fraction. So for your equation, you're going to put your A value, which is 2. In this case, your B value is a fraction with an x, goes to the 2 points, and it says good work. Even if it's a decay, even if it's decreasing, you do smallest to biggest. So negative infinity to positive infinity. That will always be your range, all real numbers. 0 to positive infinity, because it's trying to sit on 0, and it's going all the way up to positive infinity. The y-intercept is 0, comma 2. And then the asymptote is y equals 0. So once again, if you draw it on the graph like it asks, it's trying to sit on y equals 0. It's trying to reach 0. These two numbers are going to be the same. And then your y-intercept is 0, comma 2. So that's where that 0, comma 2 came from. All right, for this one, 7 is your A value. Let's come up with a pattern. I don't want to deal with decimals, so I'm just going to choose these. I'm going to work from the bottom up. 7 divided by 14 gets me a half, so that's my B value. You could have done 14 over 28, which will still get you 1/2. So then 7 times 1/2. All right, caret key X, and then check. And you can always check to make sure that your multiplication is correct, because 28 times 1/2 gets you back to 14. 14 times 1/2 gets you back to 7. So on and so forth. For the domain, once again, negative infinity to positive infinity, because this graph goes forever to the left and forever to the right. It is trying to sit on 0, and it's trying to reach the sky of positive infinity. Here it looks like the y-intercept is 0, 7, and then y equals 0. So to draw the asymptote, draw a horizontal line, y equals 0, and then the y-intercept is 0, comma 7. Okay, for this graph, it looks like 0.5. We're going to confirm 0.5 because it's on the table. A equals 0.5, and that's okay. You're allowed to have a value that is a decimal. And then I want to choose 2 and 1. So 2 divided by 1 is 2. So it looks like our B value is going to be 2, which makes sense because 0.125 times 2 gets me the 0.25. 0.25 times 2 gets me 0.5. 0.5 times 2 gets me 1, so on and so forth. And then we put it into this new equation. A comes first, then B raised to the x power. You know we did it correctly. The domain, same thing, negative infinity to positive infinity, 0 to positive infinity, 0, 0.5, and then y equals 0. Now the last slide is like your bell work slide. So let's simplify number 1. We have negative 2 times negative 1 raised to the 0 power. So let's just take care of this part. This is a 1 because the negative is inside. Drop down the negative 2. Negative 2 times 1 is negative 2. Now we have y squared, and we have x to the negative 5. So the only negative exponent is that negative 5. So we're going to keep the negative 2 because that's a base. Bases can be negative. We're going to move that x to the 5th up and make the exponent positive because we did move it up. So then this is going to be your final answer. Number 2, let's look at that negative 3 raised to the 0 power. That negative 3 raised to the 0, that negative 3 is inside, so that's going to be a 1. So then we have y to the negative 5, z to the 3rd, over x to the negative 2. Now there are only 2 items here that have the negative exponents, so we have to move location. Technically, we don't have to write that 1 anymore, so we're going to write x squared, z to the 3rd, and then y to the 5th, because the only thing that needed to move was the x squared and the y to the 5th. X squared is now in the numerator along with the z to the 3rd, and y to the 5th stays. All right, for number 3, the negative 5 stays. It's just a base. Y to the 0 becomes 1. So then I don't even need to write it because I have z to the negative 2 in the denominator. Now I have 2 negative exponents. So the z to the negative 2 was in the denominator, so now I'm moving it to the numerator. Became a positive exponent. X to the negative 6 was in the numerator, now it becomes positive because it's in the denominator. All right, number 4. Negative 3 to the 0 power becomes negative 1. Z to the negative 1 is in the numerator, so we're going to move it down. Y to the negative 2 is a negative exponent, so we're going to move it up. So y to the negative 2 moves up, and it becomes positive. That negative sign stays there. It's really a negative 1. So then it's x to the 4th, z to the 1. Now those 1s we don't need to write, so it's just going to be y squared divided by negative sign x to the 4th and then z. So the goal in this practice is honestly to remove the negative exponents. If they have a negative exponent and it's in the numerator, you move it down. If the negative exponent was already in the denominator, then you have to move it up. We're not going to touch negative bases. It's only negative exponents.